All right, I'm gonna edit it so like we're not on the clock right now, but I'm gonna say three, two, one, and then like we're starting. Okay.
Okay. So wait, how are we starting? Like,
I'm just gonna say molecule to mole, and then I'm just gonna say you'll hear me, and then when I stop talking, I'm moving to the next slide. Okay.
okay. So you're just saying the first slide?
Yeah.
Okay.
All right. Three, two, one. Hey guys, welcome to our presentation of how you do molecule to mole. So first, we need to go over some key terms. A mole, or MOL, is a scientific unit for measuring large amounts of very small entities. This is a defined number. Some examples of this are atoms, molecules, or other specified particles. 1 mole of a substance is exactly 6.0221407 times 10 to the 23rd. But it's important to note for our problems, we will round to 6.02 times 10 to the 23rd. This number comes from the fact that in chemistry, it represents the number of particles in a mole.
Second key term is a molecule, represented by an M and a capital Q. A molecule is defined as two or more atoms of the same element or different elements that are bound together. An example is H2O or water, or O2. We will explain this more on slide 3. Molecule may be homonuclear, which means it consists of atoms of one chemical element, as with oxygen, or it may be heteronuclear, a chemical compound composed of more than one element, as in water.
So, you might be wondering to yourself, what's the difference between a compound and a molecule? So, the important thing is, while all compounds are molecules, not all molecules are compounds. A molecule is formed by two or more atoms of an element joining together chemically. A compound is formed if the types of the atoms are different. Not all molecules are compounds, such as oxygen gas, which is the image to the right, which consists of only one element.
Water is also a molecule because it's made from atoms that have been chemically combined. On the contrary, water is also a compound since the atoms that form water are not all the same. The image to the left shows that because there is two hydrogen and one oxygen.
Important reminder, when converting units, you must use factor label, or else Mr. Shang will get you.
Now, time for a quick refresher on factor labeling. First, you have to make a given and find list to organize your thoughts. Then you have to put the same units on opposing sides of the fraction, thus canceling out the units so that you get the right one at the end. You have to make sure the one that at the end is the one that you don't cancel out during the process. And here we have a picture of what it should look like. Now on to sample problem 1, molecule to mole. So the problem is, how many moles are in 8.234 times 10 to the 16th molecules of magnesium peroxide? We see molecules and moles in the question, so we have to find that conversion. First, we're going to list the givens and finds. Our first given is 8.234 times 10 to the 16th molecules of magnesium peroxide, which is listed first in the problem, and 6.02 times 10 to the 23rd molecules of magnesium peroxide equals 1 mole of magnesium peroxide. This was said earlier in the presentation. And finally, our find is the moles of magnesium peroxide. First step is to put the 8.234 times 10 to the 16th molecules of hydrogen peroxide on top. And we have to begin with the first given. The next step is you have to realize that you have molecules on top. So you have to put the molecules on the bottom on the second step. You have to make sure the units cancel so that you have the unit that you're trying to find at the end. We put 1 mole on top and the molecules on the bottom. The next step is to calculate and check the sig digs. So the molecules cancel out, so we're left with just moles on the top. But the final calculation is 8.234 times 10 to the 16th divided by 6.02 times 10 to the 23rd, which gets you 1.367 times 10 to the negative 7. But you need 3 sig digs, which turns to 1.37 times 10 to the negative 7th moles of magnesium peroxide.
So for sample problem number 2, we will be doing mole to molecule. And the question is, how many molecules are in 0.95 moles of aluminum phosphate? So we see the moles and the molecules in the question, so we need to find that conversion. We will use the givens to factor label, and we will end with the finds. So we are given 0.95 moles of aluminum phosphate, and we are also given the constant for moles. And we will use this to find molecules of aluminum phosphate. So it's important to note that you should begin with the first given, as pictured here, which is 0.95 moles. Next, you need to make sure the units cancel out so that you have the unit you're trying to find. So we have moles on top when you begin. So now we need to put it on the bottom so they cancel out. And that way you're just left with molecules. So next, you calculate and check sig digs, and you're left with 5.719 times 10 to the 23rd molecules. But it's important to remember you need to check sig digs, and the final answer will be 5.7 times 10 to the 23rd molecules of aluminum phosphate. We're excited. How do I end it?